G'day and welcome to Stu's Shed. Today's going to be quite an exercise. I'm going to run through quite a number of steps on the CNC as we go through all the steps basically involved in making a product, right through from the setting up the computer in the first place, generating the G code that's going to be used by the CNC machine, router bit choice, multiple materials, right through to the end product. Well, to start with, we've got this fella here, and this is the one that I want to basically reproduce. And because we've got the router bit set here, this is the basically the CNC master collection from Amana tool, sold by ToolsToday, and it's an incredibly comprehensive set covering a whole wide range of materials, plastics, aluminium, steels, timber, manufactured materials, you name it. Basically this router set will cover it. Sorts of things I'm going to be working with include brass. I'm probably getting quite a good reflection off that because it's very shiny. I've got copper. It's a solid green by the look of it. I'm going to leave the protective covering on it at the moment because that actually helps with the machining operation. Just to basically stabilize it on the top and the bottom surface, but you can just see a little bit of a corner there. Got some of this. Now this is carbon fiber and it's not very cheap. We'll include corian. I've got foam, we've got timber, we've got melamine, I've got core flute, perspex, got MDF and got timber obviously. So there's a huge variety of materials that we can actually work with on a CNC machine. And as I say, once you've got the right router bit, then you're pretty much set up to do whatever you want with them. So to start off this evolution, the very first thing I need is a very good reference surface. In this case here, I've secured a piece of 32mm MDF to the top of my working surface. However, the very first thing I need to do, and this is true for any CNC machine, is we want to make sure that the surface of our bed, in this case the top of the MDF, is actually parallel with the top beam of the CNC machine itself. Can cause quite a bit of a change to what you're trying to do depending on the job you're doing. What I'm going to do is break out the first of our router bits. In this case it's going to be a surfacing bit, what's also called a spoil board bit. This is a spoil board bit. It's the mini insert CNC spoil board bit, RC2250 from Amana tool. It's a very interesting configuration because it's not only has got the normal cutter orientation there, it's also got these two flat pieces which are basically going to do a shaving cut to produce a very smooth, flat and feather free surface. And try saying that 3 times, feather free. Can't say it twice. So I'm just going to screw that into the spindle. Insert my router bit. Do it up nice and firmly, and it's good to go. So I've just opened up Aspire. This is some of the main software that comes from, well, basically some of the main software that's actually a program that you use to create the code for doing three-dimensional routing or three-dimensional CNC routing. Create a new file. Now we choose our material sizes. In this case I'm using a piece of material which is 600 by 600. It's 3 mil thick. I'm going to set my X, Y and Z point to this front right hand corner. Now the reason for doing that is because this is the closest corner to where I'm standing, and it makes it easy then for me to align the tool to that point. Now if I was going to use some other types of material or different sizes, and I just wanted to use a scrap or something like that, then I'll probably reference off the center and do a center line one. But in this case I've got a good reference point in the corner to start my start working from. Let's go to click OK. File, I'm going to import a vector. Choose my plans. In this case I'm choosing the dragon. Go into the DXF codes, router, millimeter, and I'm choosing our 3 mil design. And here it is here, looking, as I said, a lot larger than the actual working area. Now I've got my design, I've got my plans, and I've chosen which components are going to be cut out of. I've chosen the components I'm going to have cut out of different colours, and I've marked them all up. So now I'm just going to go through and select the ones that I actually want. I'm just going to put them to one side. And while I'm going to delete everything that is not going to be that colour. Okay, so I've identified all the components that I want to have in this green plastic. Now rather than me trying to move them around and fit them on the screen, what I'm going to do is highlight them all. I'm then going to move over here to the nesting option. Now I've set the tool diameter larger than what I'm actually using in this case, and a little bit more clearance, just because this is quite a brittle material, and I just want to make sure that although I want to sort of optimize the amount I actually use it, I don't want to get it so close that they end up breaking. I'm going to nest from that corner along the y-axis. I'm going to preview that. It will then do a quick analysis of all the parts, and then it will try to group them onto the material, making the best use of the material that I have available. In this case I have more than enough to do the job. Right, now we can see that the layout gives us plenty of clearance around each piece, but it's still giving us quite a bit of spare material. So I click OK onto that. Now I'm just going to highlight them all again, and now I'm going to go and generate the toolpath. Now I'll just pin my menu open so it doesn't keep opening and closing, which I find very annoying. In this case I'm going to choose a profile toolpath because I'm cutting around each of these objects. Starting depth at 0, that's fine. Cut depth 4 mil. In other words, I'm actually going to cut right the way through the plastic into the backing board by about 1 millimeter or so, just to make sure that we get a good clean cut and we don't sort of leave the pieces almost cut free but not quite. We'll choose the tool we're going to use. In this case I'm going to select, now we're using an 1/8 inch diameter, which is 0.125 inches. Now what I'm actually going to do is I'm going to cheat slightly. Actually change that to millimeters so we can see what's going on. I'm going to make it 2.95 millimeters with a pass depth of 2 mil. Now the feed rate's way too high. Now I'm going to drop that right back down to 10 millimeters a second, and with a plunge rate of also 10 millimeters a second. That's about right. Now the reason I'm going slightly under is because the plans can be that close in their tolerances that if I don't fake it slightly with the actual diameter, it may not do the individual slots that we need to do for the parts to join together. Apply that, click OK. Go into edit passes. Now I can see that it's going to do a pass depth, one cut at 2 mil and the next one at 4. Now it should be alright. I'm going to go OK on that. Direction, climb is fine. That's okay. Now we're going to add some ramps to the toolpath, because again we're cutting into plastic and I don't want to try and plunge the bit straight down. I actually want to ramp it down into the material slightly. I'm going to do it over a short distance. I'm going to do it over about 5mm should be alright. That's fine, and I'm going to add tabs to this as well, just so each part is is held in place while we're doing the cuts. Now I'm doing a 4mm length of tab, 4mm thick. Now don't forget, a millimeter of that's already lost because it's assuming that we're going down to 4mm and the material's only 3mm thick. I'm creating a 3D tab because that makes it quite easy to break these loose after the fact. Now go into edit tabs. Now I don't like how the program assigns tabs automatically, so I'm going to add my own tabs manually, and I'm just going to choose a couple locations on each component where it's supporting the material nicely. Let's remove that one and move it. So it's supporting the material nicely, but also somewhere that I can then machine it away easily. So for example, this one here I'm putting on the outside of the curve. It's very easy to get to. If I put this one on the inside here, it'd be very difficult for me to sand that one away, or harder, so I'd rather not put it in there. And the last one is there. Okay, that looks like all the tabs are done. Let's close that. And I then calculate, and this is now going to calculate the path. Now the one thing it's telling me, I'm going to be cutting all the way through my material. That's good. That's exactly what I want to have happen. There is the profile. Well, sorry, there's the tool path. We can preview that if we like. As beneficial as that is. Close that. I'll just click on that tool path again. Save it. Save tool path to file. And that's all I need to do in Aspire. Right, so I've moved over to the use CNC software button. I'm just going to click on Home All just to make sure the machine knows exactly where home is. I'm just going to bring I'll manually jog the machine over to the front area. Let's take this off. So the router bit I'm going to use now is this one here. It's a 51411. It's a 1/8 inch router bit, 1/4 inch shank. It's got a 1/2 inch cut length, and it's designed to give a mirror finish with an upcut in plastic. That's exactly what I'm looking for. Insert the router bit, so plenty of meat inside the collet. Do that up firmly. As I said before, I'm going to leave the wrapper on this just because it provides a little bit of extra support to material. Lay it down. Now I've actually already got a couple of holes drilled in it, so I can just screw that down straight to the my sacrificial board. Now, as I said earlier, what I'm going to do is I've used that front right hand corner as my reference point. So I'm just going to jog the machine over to there to zero the cutter to that point. Let's get it close. Now I'm going to zero all that, and then what I'm going to do is actually just move the cutter over a little bit into the material, and then decrease my jog feed right down so I can zero off the Z-axis. Zero that. I'm just going to then lift that up out of the way. Okay, that's all set, ready to go. Now I'll just load my file. Dragon. So I've had a couple of pieces pop loose already, but that's the first pass, and most of them are there. They're only held in by quite small tabs, so it'll be very easy for me to remove them. So what I'll do now is, just off camera, I'll just pop each of them out. I'll take the paper covering off, and then just give the edges a quick touch up on the disc sander, just to get rid of where the tabs were. For this next job, we're going to now change over to aluminium, and it's not a material I've done pretty much any work with on a CNC machine before, so this will be quite an experience for me as well. Going to change the route a bit over. We're now going to, now let's just choose the right one. We're going to this one here, which is 51474. It's a 1/8 inch diameter, 1/4 inch shank, and it's also got a 1/4 inch cut length. Now I'm going through a reasonably short cut length, again, because I don't want to, well, I'm not quite sure how it's going to perform, so I don't know how much load I'm actually going to be putting onto the cutter with the settings I've chosen. So if I go for a short cut length, then it's basically just doesn't have that much opportunity to flex unreasonably if I've chosen a setting which is a little bit faster. So with router bit 51474, which is the 1/8 inch aluminium routing bit, we've managed to cut all these out very, very successfully.